Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now through this problem, we are going to work out that how the angles of inclinations, they are going to affect the projections of the solid which are going to be obtained onto any given reference plane. So here you see we have got a right regular hexagonal pyramid. The edge of the base is given to us, it is equal to 25 millimeter. Height of the axis is given to us 50 millimeter. It is resting on one of its base edges. Just see, it is resting on one of the base edges on the horizontal plane with the axis parallel to the vertical plane. So the axis is parallel to the vertical plane, and we are required to draw the projections of this hexagonal pyramid when first of all its base is making an angle of 45 degree with respect to the VP. That is, base making an angle of 45 degree means axis is also inclined at an angle of 45 degree to the horizontal plane. And in the second case, the axis is inclined at an angle of 30 degree to the horizontal plane. That is, its base will be inclined at an angle of 60 degree to the horizontal plane. So we are trying to evaluate how the changes in the orientation of the solid with respect to a particular reference plane, they are going to affect the projections which will be obtained on the horizontal plane. So let us first of all evaluate the basic shape of the hexagon which will be drawn onto the horizontal plane. You see, in this case we are provided with the fact that this hexagonal pyramid is resting on one of its base edges in HP, and the first angle of inclination, which is the only angle of inclination of this hexagonal pyramid, is with respect to the horizontal plane. So since this pyramid is inclined to the horizontal plane and it is having one of its edges on the horizontal plane, so to begin with we are going to assume that this solid will be standing upright while it will be resting on its hexagonal face onto the horizontal plane. So this is the base of the hexagonal pyramid which will be lying onto the horizontal plane. So this will be viewed as a true shape in the top view, and this will be drawn below the XY reference line. Now we have to work out which of these two orientations will represent the correct orientation of this solid. Now if I locate my solid into this orientation, that is, if the hexagon is located into this orientation, and if I try to tilt it either this way or this way, what is going to happen? It will be resting on the horizontal plane on one of its corners. Just like you see, this is the solid, I have to tilt it this way or I have to tilt it this way. So it will be resting on the corner C or F over there. So if I locate it this way, then I have to tilt it this way or I have to tilt it this way. So it will be resting on the corner of its base on the horizontal plane, which is incorrect. Why? Because I have been provided with the fact that this hexagonal pyramid rests on one of its base edges in the horizontal plane. So you see, if I draw this hexagon, which is the true shape of the base of this pyramid, so then if I draw it in this orientation, now it is just like the model which is shown over here, and then if I tilt it either this way or if I tilt this hexagonal pyramid in the other direction, either way around it will be resting on either the edge of the base AB, or if I tilt it this way it will be resting on the base edge ED. So you can tilt it this way towards the right or you can tilt it this way towards the left. So if you're tilting it towards the right, it will be resting on this edge. If you're tilting towards the left, it will be resting on this edge. So this is the correct orientation of this hexagonal pyramid with respect to the vertical plane. That is, we are going to have one of the edges, rather both of these edges, they will be perpendicular to the vertical plane. So let us start drawing the projections. So the edge of the base of the hexagonal pyramid happens to be 25 millimeter. So let us draw the hexagon. So XY line, reference line we have drawn. Now this is the edge of the base, and this edge of the base happens to be perpendicular to the vertical plane, and this base edge is resting on the ground, that is onto the horizontal plane. So we are going to draw the top view, which will reveal the true shape of the top view of the base over here. So let us do the marking of the points. So the edge is 25. Now A, B, C, D, E, F. So these are the 6 corners of the base of the hexagonal pyramid. Now we can join the diagonals AD, BE and CF, and the moment we join these diagonals over here, so we are going to join them dark. Why? Because all the slant edges, that is OA, OB, OC, OD, OE and OF, all these slant edges of this hexagonal pyramid, they will be visible to us from the top view. So we locate the axis point for this particular hexagon while we have joined these 3 diagonals. And then since it is a pyramid, in case of a pyramid, all these slant faces we can see. This is first slant face, this is the second slant face, third slant face, this is the fourth slant face, this one is the fifth, and here we have the 6th slant face of the hexagonal pyramid. So the center point has been located. So O is the axis point for the top and O1 is the axis point for the bottom of this hexagonal pyramid. So the height of this hexagonal pyramid is provided to us as 50 millimeter. So having located this point O over here, so this O dash will be located 50 millimeter above the XY reference line, so that the height of this hexagonal pyramid will be 50 millimeter axis of this pyramid. Now we are going to join these lines over there. So these are the projectors. So you see projector drawn through B and A, it will be appearing onto the XY line, that is onto the horizontal plane. So since this base, that is ABCDEF, happens to be perpendicular to the vertical plane and it is lying on the horizontal plane, so the projections of the base will be available on the XY line, that is on the horizontal plane. So the projections through B and A, we'll get B dash and A dash over here. Projections through C and F, they will be available on XY line as C dash and F dash. Projections through D and E, they will be available on the XY line in the form of D dash and D dash. So O1 dash is the axis point at the base and O dash is the axis point at the apex or the vertex. Now we are provided with the data, that is the base is making an angle of 45 degree with respect to the horizontal plane. So this triangular front view that we have obtained in the first step, this has to be rotated at an angle of 45 degree. That is, it will be inclined in this way. So let us see in which way we are going to incline it. So whichever way we incline, either this way or this way, towards right or towards the left. So it will be resting on the edge of the base on the horizontal plane. So we have tilted it towards the right side over here. So now we are going to mark these 3 points, 1, 2 and 3. So these 3 points we are going to transfer onto the locus projector line, which is marked at an angle of 45 degree, so that the base of this front view, that is base of this hexagonal pyramid, will be shifted or rotated at an angle of 45 degree. So now point 1, point 2 and point 3, so they will be located over here, and from point 2 we are going to mark the vertical axis as equal to axis length of this pyramid, which is equal to 50 millimeter. So this O dash O1 dash distance is equal to 50 millimeter. So from here point 2 we are going to draw a perpendicular. So this will help us to locate point O1 dash. So if the angle of the inclination of the base is 45, so obviously the axis will also be inclined at an angle of 45. Since this is a right regular hexagonal pyramid, so the axis of this pyramid is perpendicular to the base of the pyramid. So let us work out all the points, projections over here. So D dash, E dash, it will be located onto the ground. So now our hexagon is inclined with respect to horizontal plane with base making an angle of 45 degree to HP, and it is resting on one of its edges, which is the edge DE. So it is resting on the edge D1 dash and E1 dash onto the ground or onto the horizontal plane. So having marked this distance 50 millimeter over there, now we can join this projector dark, this one and this one also dark, right? So all these same projectors which were dark, they will be drawn over here. That is, this figure has been replicated over here. So having drawn the front view, now we need to draw the top view of this particular hexagonal pyramid. So how many points were there into this elevation projection image? 6 points corresponding to the base and 2 points corresponding to the axis. So in all 8 points are there into this elevation view. Similarly, you can see there are 8 points which are available in the plan projection view which we had drawn before. So the horizontal projectors from the plan projection view, that is previous plan projection view, will be drawn, and the vertical projectors through the elevation view which has been drawn, they will be worked out, and we will work out the corresponding points of intersection, and wherever the points of intersections are there, the coordinate locations of the points in the plan view will be located. So just see, we draw the vertical projector through A1 dash and draw the horizontal projector through the plan projection view, that is previous one. Wherever these two intersect, we get the location of point A1. Similarly, draw the vertical projector through B1 dash. Wherever it intersects with the horizontal projector through B, we get the point B1. Similarly, from C1 dash, you draw the vertical projector line and draw the horizontal projector line through the previous plan projection view, that is C point. So wherever these two projectors they meet, you get the location of the point C1. For D1, you draw the vertical projector from D1 dash and draw the horizontal projector through the point D, that is plan projection view for previous one. For E1, once again, draw the vertical projector through E1 dash and draw the horizontal projector through E. This gives us point E1. And finally, you have for F1 dash, draw the vertical projector through F1 dash and draw the horizontal projector through the previous plan projection view point F. So all the points of the hexagon, they have been located. Similarly, for the axis points, so from O1 dash, drop the vertical projector line and draw the horizontal projector from point O of the axis. So you get point O1. And finally, for the base axis point, from O11 dash, draw the vertical projector line, and then from O1 point of the plan, you draw the horizontal projector line. So all these projections for 8 points, they have been evaluated. Now since you see we are looking from the top, so whichever points they lie farthest away from the observer and closest to this reference line XY, these are D1 dash and E1 dash. So all the edges or the lines joining D1 dash and E1 dash, they will be drawn dotted unless they are the part of the outer boundary of the object. So let us start drawing these points over there. So we understand one thing very carefully, that A1, B1, C1, D1, E1, F1 will be joined, and then O1, A1, O1, B1, O1, C1, O1, D1, O1, E1 and O1, Fn will be joined. So these are the lines which need to be joined. Only thing is we need to work out which of these lines or the edges will be drawn dotted, that is hidden one, and which ones of these lines they will be drawn dark, that is the object line. So you see, these are the lines which are to be joined with E1 and D1. These will be drawn dotted. Why? Because since we are looking from this side, so points D1 and E1, they are farthest away from the observer and they are closest to the plane. So all the edges which are joined through D1 and E1, they will be drawn dotted. Similarly, D1 O1 will be dotted and O1 E1 will also be dotted, right? So rest everything will be dark over here. So these are the projections, that is the top view projections of the hexagonal pyramid whose base or the axis is inclined at an angle of 45 degree with respect to the horizontal plane. Now we want to now work out if this angle is changed, how does it make any difference onto the projections over here which will be obtained in the top view. So once again we are going to transfer this figure over here with axis making an angle of 30 degree to the horizontal plane. So axis making an angle of 30 degree to the horizontal plane means that the base is making an angle of 60 degree. So to begin with, we'll be making an angle of base equal to 60 degrees so that the corresponding axis inclination with the horizontal plane will appear to be 30 degree. So let us start doing it. So once again, we are shifting this figure over here. So whatever the elevation view we had obtained, so once again we are going to rotate it towards right so that the hexagonal pyramid will be inclined towards right so that it will be resting on the ground on the edge DE. So once again please check, we are going to transfer the same image same way, point 1, point 2, point 3. So point 1, point 2, point 3 will be marked. From point 2 the vertical projector length will be 50 millimeter, which is the axis height of this particular hexagonal pyramid. So let us put down the points over there. Just see, initially we have transferred the base at 60 degree, but we were provided with the data that the axis is inclined at 30 degree. So we have to rub this off. This is only to make the construction easier, to make sure that this edge, that is D dash E dash, that is D2 dash E2 dash over here, it will be resting right over here onto the ground. So now we have rubbed this off. Now let us do the marking of the points. So D2 dash E2 dash will appear here. C2 dash F2 dash, which is corresponding to the point 2, will appear here, and B2 dash A2 dash, which is corresponding to point 3, will be appearing here. And then the perpendicular distance 50 millimeter will give us the location of the apex point O2 dash. And then we can join this projector as well, that is, this is my slant edge projection in the front view for OF and OC. And now you see, these are the projections which are obtained assuming that the axis of this particular hexagonal pyramid is inclined at an angle of 30 degree to the horizontal plane. Now we need to obtain the projections of this hexagonal pyramid in the top view and see to it how does the change in orientation make a difference regarding the projections which will be obtained on the horizontal plane. So once again the corresponding points, they have been located. So projector through A2 dash and projector through A, it has provided us with A2. Projector, vertical projector through B2 dash and horizontal projector through point B over here, it has provided us with the point B2. Similarly, vertical projector through C2 dash and the horizontal projector through C, it has provided us with C2, and D2 has been obtained as the point of intersection of vertical projector through D2 dash and horizontal projector through point D. Similarly, E2 point, it is the intersection of vertical projector through D2 dash and horizontal projector through E2 or E point over here. And finally, for the hexagon, you draw the vertical projector through F2 dash and draw the horizontal projector through the point F. So all the points of the hexagon base, they have been obtained. Similarly for this, that is the axis point, draw the vertical projector through the O2 dash and the horizontal projector through O. So this gives you O2, and this is O21. Draw the vertical projector through O21 dash and horizontal projector through O1. So all these points, they have been located. And similarly, once again, we are looking from the top side. So farthest point is D2 dash and E2 dash. So once again, just like in the previous case, all the edges or the lines which are going to be joining D2 and E2, they will be drawn dotted, because D2 dash and E2 dash, they are the points which are closest to the XY reference line and they are farthest away from the observer. So let us start joining these points. So after joining, just see, this is figure 1. This is the projection which is figure 2, top view. Now we can see that as there is change in orientation, that is inclination of this hexagonal pyramid with respect to the horizontal plane, there is change in the shape. That is, the angles will decide, that is, the orientation will decide that how the projections they will be obtained onto any given reference plane. So this was the basic objective behind taking up this particular problem in this lecture. So in this lecture we have understood that if the angle of orientation of any given solid is changing with respect to the reference planes, so its projections on that reference plane, they will also be changing depending upon the orientations over there. So this is all about the study that we had taken up. So thank you very much. Thanks a lot. Thanks a lot.